Okay, hello and welcome to Math 2. We're going to do 29 to 35. So the first one, 29, doesn't really require you to do a lot of work. It only really requires you to maybe try some guess and check. So what it's asking for is an actual equation. You have to kind of sort of make it up on your own. When you plug in a 10 into the machine, you crank it out and then you get a 99 as a result. When you plug in a 2, the same thing, the same machine, the same functions should produce a 3. When you plug in a -3, you should get an 8, and then so on and so forth. So I'm just going to put this out here because I don't really want you to spend too much time trying to do this. But the actual equation is x squared minus 1. So you can check. If you plug in a 10, then it would be 100. Minus 1 would be 99. If you plug in a 2, squared would be 4, minus 1 would be 3. If you plug in -3, -3 squared is, in parentheses, -3 squared is 9, minus 1 would be 8, and so on and so forth. If you plug in a 0, 0 squared is just 0, minus 1 is -1. All right, there you go. That's 29. 30 is what we've been doing in class for the past 2 days. So it basically wants you to graph -2 times x minus 3 squared plus 2 without a calculator. So it should go on an xy pretty accurately, I think. It shouldn't be too difficult to do. Without a graphing calculator and without making an xy table. And then it wants to know the x and y intercepts. So the learning log that we basically did today should be able to help you out. You already have the graphing form, so you should be able to tell me that the vertex is at 3, 2. So I have, I guess we could use this side here. Okay, so there it is. So 3, 2. I'm going to put this over. So we have f of x equals -2 times x minus 3 squared plus 2. So your vertex, we know for a fact, is at 3 and up 2. Here's your vertex. Okay. Vertex. What is this? 3, 2. Alright, so there's a -3, so it's going to be a +3 for the x, and plus 2, so it just goes up 2. Alright, and then it's a -2, right? So it's going to go down, and before I even do that, I want to know where the x-intercepts, where's the y-intercepts. So from the learning log, to find the x-intercepts first, we plugged in 0 for the f of x. So this would look like, okay, so 0 is equal to -2 times x minus 3 squared plus 2. All right, and then I'm going to subtract 2 to both sides, so -2 minus 2. So I have -2 equals -2 times x minus 3 squared. Sorry if you can't see, I will zoom in. There you go. And then, so from the learning log today, right, you can't take the square root right now, so you have to divide. And then, lo and behold, that actually gives you 1 for each of them. So 1 is going to equal, well, that's just 1. So I'm just going to leave it as x minus 3 squared. Okay, now you can solve. So now you take the square root of both sides and then get plus or minus 1 is equal to x minus 3. All right, there we go. And then you should get +1 equals x minus 3, or -1 equals x minus 3. Add 3 to both sides because it's +3 plus 3. So you get 4 equals x plus 3 plus 3. We get 2 equals x. Okay. If you have no idea what I'm doing, then that's not good. So you should get x equals 4, x equals 2. So now I know for a fact that it's going to hit at 2 and it will hit at 4. I think I did that right. Yep, I think we're good. All right, and then the only last question is, where's the y-intercept? All right, well, the y-intercept, you plug in x0. So I'm going to just take it straight out as y equals -2 times 0 minus 3 squared plus 2. So we get y equals -2, -3 squared plus 2. So y equals -2 times 9 plus 2 No, you cannot do -2 times -3 first. That is not allowed. Exponent first. So that's -18 plus 2. So then your y-intercept is going to be equal to -16. All right. So somewhere down here at y equals -16, I don't know, it's all the way down here. I don't even know where it's at, but it's going to be out in the boonies. Okay. It's not drawn to scale, obviously, because this is not 16. So it's going to come down in this direction, go through here, and then just kind of taper off in that direction. All right, there you go. That is number 30. Okay, now 31 is different. 31 might give us some problems. All right, so that was 30. 31. I actually cannot believe that they actually stuck this inside the homework. Whatever. All right, so write the equation of function graphing form from each parabola described below. So parabola with a vertex is 0, -5 that passes through a point -1, 2. So basically, if you were to graph this, right, you'd have something like 0, -5. Okay, well, it's over here. Oh my God. 0, -5. Down here. And it passes through -1 right over here. And +2 over here. Now the only question is, this is the vertex, so obviously it's not going to go down, because that would mean they would not touch that point. So at some point it does have to make it through there and come back up the other side. The problem is you don't know exactly if it's really skinny, if it's really wide, like you don't know, so you need something, right, besides just, oh, it's going here. But you can use the fact that the vertex is 0 and -5. So I'm going to plug this in the graphing form. The graphing form said that, well, if you have any function, A was the number in front that made it go skinny or wider, right? So either compressed it to make it wider or stretched it to make it skinnier. This was the number out in front, and then it was x minus h. This h was your vertex for the x and squared, and then it was like plus k. That was the form for the graphing form. It's not that you should memorize it. I mean, you should, but you'll get it eventually. So I know that this is the vertex. So that means this is the h and this is the k. That's the h and the k. So I'm going to plug this in. So this is going to look like, okay, well, I'm just going to go y equals a. I don't know what the a is, but I know it's x minus 0 squared. And then k is the minus 5. Oh, let's just say 5. I don't know why I did k. Okay, that's it so far. So this was the h, this was the k, that was the h, this was the k, it's minus 0. So this is almost complete, apart from the fact that we're missing the variable a. We need to know, is this going to be a skinny one or is this going to be a pretty wide one? So we need to actually solve for this. But in order to do this, you can't just solve it right now. You have an a, an x, and a y. You have 3 variables. It's not going to work out for you. But we do have this other wonderful point over here, -1 and 2. This is like the x. This is like the y, obviously. So this I'm going to, in place instead of the y, I'm going to put a 2. A is still a. I don't know what it is. Instead of the x, I'm going to put a -1. Okay. Minus 0 is just minus 0, it doesn't really matter, and then minus 5. All right, well, now we have 2 equals a times -1 squared is just 1. This is just -1 times -1 minus 5. So that's the same as a minus 5, because 1 times a is just a. Then I get plus 5. Then I get 7 is equal to a. And lo and behold, now I know it's an extremely skinny graph because that's a 7. So as a final answer, you get y equals 7. Let's go back to the original. It's kind of like finding the mx plus b and finding the b and then having to go back in and plug it. And then you get x minus, what is this? what was it? Oh, 0, I guess. Okay, well, I'm just going to leave the 0 there. And then minus 5. So this was the equation of the graph. It's a really skinny one, right? Goes up because A was still positive. Okay, this is what you need to do with part B. All right? It's the same setup, it's just having you practice it over again. You need to do it on your own. I'm not going to do part B with you. All right? There's A. If you have any questions, you can see me, but I think it's pretty well laid out. The 0 and the -5, and 0 and the -5, and the x and the y. There's the x and the y. In this case, it's you have a 1 and a 4. Oh, shoot. Okay, I might actually have to do this with you. Okay, scratch that. We might have to do this with you. Okay, so let's plug this in. So we have y equals a x minus 1 squared plus 4. Okay. There's a vertex, minus 1 plus 4. You have 5 and -4. Oh, no, I don't need to do this with you. X and y. -4 equals a times x is 5. So 5 minus 1 squared plus 4. Oh, you could do this on your own. Okay, I'm going to stop there. Solve for a, please. And then plug it back into the equation. All right, that's 31. 32. Is an inequality thing. Okay, there's the thing, but I'm not really so much concerned about that as I am about making sure you actually understand that it's a word problem you need to solve. So Brad says to his daughter Kayla, even if you squared your age and added 1, you still wouldn't be as old as I am. So Brad is 65 years old. So there's the inequality. So squaring Kayla's age, hey, it's Kayla. Even if you squared your age and added 1, you still wouldn't be as old as I am. So it's, if you can't see, Kayla's age squared plus 1 is less than the granddaughter, so Brad, I guess, is grandpa, 65. All right, and you need to solve this. If you don't know how to solve this, please look at look at the first video in this chapter, because I went through how do you solve an inequality, and then you eventually do find out that 8 is the answer, because 8 squared is 64 plus 1, no. Oh, it has to be less than 8 years old. Okay, that makes more sense. Because if you put 8 in here, it'd be 8 squared plus 1, which would be 64 plus 1, which is 65. 65 cannot be less than 65. Doesn't make any sense. So she has to be less than 8 years old for this to work out. And obviously, she stops at 0 because otherwise you can't have negative numbers. All right. So please make sure you fully understand how to solve that problem right there. You just square root. Make it equal to, and then solve it. Doesn't matter if it's an x squared, you still set it up the same way. You have your k squared plus 1 equals 65. Solve it like you normally do. K is equal to whatever it is. You get plus and minus something, and then you got to check it. Obviously, the minus isn't going to work out for you in this one. All right, 34. So simplify each of the expressions. Be sure your answer has no negative or fractional exponents. Okay, let's take the first one. We're going to take these one at a time. -1/4. Okay, so 1 over 16, as far as I know, is the same as 1 over 4 squared. -1 over 4. Okay. 1 over 16 is the same as 1 over 4 squared. 4 squared is 16. Well, if it ended up on the bottom, that means it must have been -2 up. 4 to the -2 is the same as 1 over 4 squared. -1 over 4. And then if this is like this, then technically you can say, okay, well, 4 times -2 times, actually, so -2 times -1 over 4, because that's what's happening up here. That's the same as -2 times 1, that's a 2, 4 times is a 4, so that's like 1/2. Okay, so that's like 4 to the 1/2 power. There. This right here, I should do this in a different color. Okay, I did the work for this over here in this spot, and then the 1/2 came from the answer, this portion right there. So 4 to the 1/2 power is the same as, well, the square root of 4. So the square root of 4 is a wonderful 2. There you go. Square root of 4 is the same as that one. Alright, next one. X to the negative, y to the third. Okay, well, I'm just going to move them all to the bottom. So this is x to the first, y to the third. And then I think that's it. There's nothing else. X's and Y's. That okay? Well, that's done. Oh, that was silly. All right, so let's do this one. 25 x to the fourth to the half power. So 1/2. Let's see how I want to do this, because there's like 2 different ways to start. Probably like 3 different ways to start. We'll do the easy way. Okay, so 1/2, like we did in the first one in A, anything the 1/2 power is just like taking the square root of it. So I'm just going to take the square root of 25x to the fourth. All right, there we go. Okay, so that means I have 5 times 5, and then I have x times x times x times x. Okay, there's a pair of 5s, there's a pair of x's, then another pair of x's. All right, this is super convenient. That means there's nothing left over under the radical sign. Oop, it's empty. But there's a pair of 5s, so one of them comes out. There's a pair of x's, one of them comes out. There's a pair of another x's. There's another pair that comes out. There's nothing left over, so we don't really care anymore. Technically, there's a 1 left over. So, but the square root of 1 is just 1. So I'm just it's gonna go away. Sorry. To those of you that are really picky, there's a 1 left over, technically. But square root of 1 is just 1. So this becomes 5x squared. Da-da-da. Done. Alright, if you have any questions, see me.